Okay, so these questions are all going to be about calculating acceleration. So this one wants us to calculate the average acceleration if it goes from rest, or 0 meters per second, to 30 meters per second in 12 seconds. So average acceleration is calculated using this equation here. We know the final speed is 30, the initial speed is 0, so we find the difference between those, divide by 12, gives us 2.5 meters per second squared. Okay, so a cyclist travelling at 10 meters per second at the top of a hill reaches a speed of 15 by the time he gets to the bottom. If it took him 10 seconds, what is the average acceleration? So the only difference with this question is instead of subtracting 0, we subtract 10 because that was the initial speed. So the speed has changed by 5 meters per second. Divide by 10 gives us 0.5 meters per second squared acceleration. A train is travelling at 50 meters per second. It brakes as it comes into a station. It takes 15 minutes to come to a rest. What is its acceleration, assuming the acceleration is constant? So if acceleration is constant, acceleration and average acceleration are the same number. So we can actually use this equation still. The difference is the final velocity is 0, the initial speed is 20, so we're going to get a negative number when we do this. We're going to get an acceleration of minus 1.3 meters per second squared, or a deceleration of 1.3 meters per second squared if you like. Okay. So the car starts and rests and accelerates at a constant value of 2.5 meters per second squared for 8 seconds. What speed has it reached by this time? So what we're going to do is we are actually going to rearrange this equation slightly, and in place of delta v, we're going to put the final speed v minus 0 because it started at 0 meters per second from rest. And then what we can do is get rid of the 0, multiply the acceleration by the time, and that gives us our final velocity. And just a little thing with these videos, I usually use v as the final velocity, and if we've got one, I use u as the initial velocity. So a cyclist travelling at 5 meters per second has an average acceleration of 2 meters per second squared for 5 seconds. What speed has she reached by this time? So again, what we're going to do is we're going to rearrange the equation, and this time we're going to have v minus 5 because the initial velocity was 5. So then we take the 5 across to the other side, and we get the expression which we can calculate, and we get a speed of 15 meters per second squared because we've had an increase in 10 meters per second. Okay, so the graph shows the journey of a sports car. Calculate the acceleration at each stage of the journey. So remember, acceleration is the gradient of a velocity time graph, but we've got lots of straight line sections, so that's quite straightforward to calculate. So for the first section, we're going to do calculate the acceleration like this. The final velocity I've said is about 23. The initial velocity is 0, which is why we subtract 0. That will happen over 10 seconds, giving us 2.3 meters per second squared. The next section we can see is going to be a smaller acceleration because the gradient has got shallower. So again, we can plug the numbers in, and we get our 1.7. So it is indeed slightly smaller. The next section, we can see the acceleration is actually 0 because we can see that it's a horizontal line. The velocity doesn't change. The next section, we can see we're expecting to get a negative acceleration because the velocity is decreasing here. So when we plug that in, it finishes that section at 0. It started at 40, so you can see we get minus 8 meters per second squared. The next section we can see again is 0 because we've got a horizontal line. The next section we can see we've got another negative acceleration because we've got a negative gradient, but in this section the speed is actually increasing. It's just increasing in the negative direction. We get an acceleration of minus 2 once we put our numbers in, and then finally we've got an acceleration of 0 because the velocity is constant at minus 10. All right, so final question, describe this journey. So we're basically just putting into words what we've just figured out. So the first section, we've got a constant acceleration of 2.3 for 10 seconds. Then we've got constant acceleration of 1.7 for 10 seconds. We've got constant velocity of 40 meters per second for 10 seconds. We've got constant deceleration of 8 meters per second squared for the next 5 seconds. It's stationary for 5 seconds. It has a constant negative acceleration, and it's really important we don't use the word deceleration here because speed is actually increasing during the section. So it's constant acceleration of -2 and then constant velocity of -10 for the remaining 5 seconds. And that completes this video on acceleration.